Hello everyone. Good morning. I am Dr. Vikas. So today we study the concept of hybridization. Along with hybridization, we also study the concept of covalent covalent bonding. Okay, so let's start from our topic hybridization. Concept of hybridization tells that firstly what is hybridization, or we can say the simply words hybridization. Hybridization means the atomic orbitals of slightly different energies combines to form give hybrid orbitals. Hybrid orbitals. And from with the help of concept of hybridization, we can easily explain the molecular structure and bonding in covalent compounds. And covalent compounds like BF3, or we can say water, PF5, SF6, different type of molecules, or we can also the NiCN4 2 negative. Okay, and in all of these molecules, there is a covalent bond between, like in the case of the BF3, there is covalent bond between boron and chlorine. And for the formation of the covalent bond, there is a requirement of one unpaired electron. Each of the atoms have one unpaired electron. If there is single bond, then each of the atoms have one unpaired electron. If there is double bond, then two. Both of the atoms have at least two unpaired electrons. Okay, and the number of bonds an atom can form with other atom is totally depends on the number of unpaired electron available on that particular atom. So if we take the example of boron atomic number 5, electronic configuration 1s2, 2s2, 2p1. In the valence shell of the boron, in the valence shell of boron atom, there is an three unpaired electron. These are the valence shell. Okay, and this cell is the close to the nucleus. There is an three unpaired electron, so the boron form three covalent bond. Okay, so after theoretically studying the what is covalent bond, now with the help of their graphical diagrams or atomic orbitals diagram, we can further understand the concept of covalent and ionic bond. So firstly we see that ionic bonds. Ionic bonds means there is cation or anion. Cation and anion. Cation means positive charge and anion means negative charge. In the example of NaCl, there is Na positive and Cl negative. Okay. Uh, Sodium atomic number 11 and chlorine atomic number is 17. Okay. Sodium is an reducing metal or have low ionization energy, and sodium converts into Na positive plus electron easily. And chlorine has an electronegative element, so lose by the electron lose by sodium atom easily accepted by chlorine, and chlorine converts into Cl negative. Okay, that gives Na positive Cl negative, or you can easily see that there is a transfer of electron from sodium to chlorine. Okay, and in the previous slide we have studied the concept of covalent bond. Here we have taken the example of water molecules H2. There is oxygen and hydrogen. There is a covalent bond in between oxygen and hydrogen atom. There is a covalent bond between oxygen and hydrogen. Okay. This one is the oxygen in red color, and sky color is hydrogen, and this one is also hydrogen. The electron is the one hydrogen, atomic number 1, have only one s1, electronic configuration 1s1, has only one unpaired electron, 1 1. If we talk about oxygen atom, this one is hydrogen, and this one is also hydrogen. Okay, oxygen atomic number 8, electronic configuration 1s2, 2s2, 2p4. Okay, 2p4. Firstly, I draw 2p4, 1, 2, 3, 4, and there is two unpaired electron. One hydrogen form with this unpaired electron, and one hydrogen form this unpaired electron, and there is the form of two covalent bond, 1 and 2. ओके, आई होप आपको कोवलेंट बॉन्ड और आयनिक बॉन्ड का कंसेप्ट समझ में आ गया होगा. अगेन यू कैन सी दैट देयर इज एन sharing of mutual sharing of electron, mutual sharing of electron in between two bonded atom. This one is atom 1, this one is atom 2, and sharing of available valence electron, and that give covalent bond, and this is the covalent molecule. Again, this is the example of hydrogen, uh, one electron from oxygen atom, one electron from hydrogen atom. Again here one electron from oxygen atom and one electron from hydrogen atom. Okay, this one is the example of water molecule. So for the formation of the covalent bond, there is a requirement of unpaired electron. That means, according to that simple concept, if there is no unpaired electron, there is no covalent bond. If there is no unpaired electron, there is no unpaired electron, there is no covalent bond. In the case of the beryllium, atomic number is 4, electronic configuration 1s2, 2s2. There is no unpaired electron, so no bond formed. In the case of boron, there is only one unpaired electron. This is the monovalent, and only one unpaired electron. So one bond is formed. In the case of the carbon, there is two unpaired electron and only two unpaired electron. That means this one is the divalent and two bond is formed. Clear? But when the different covalent compounds are studied, it is found that beryllium is divalent, Bf2, BH2, and the structure is this one. Geometry hybridization is sp, geometry is linear. And in the chemistry, the covalent compound shown by boron is trivalent in nature, Bf3, BOH3. This one is Bf3, sp2 hybridization, or trigonal planar is the geometry. And the carbon shown tetravalent compounds such as CH4, CCl4. This one is the tetrahedral compounds. Tetravalent is an valency. So in the previous concept, according to the covalent bonds, if there is no unpaired electron, then no covalent bond is formed. But in the chemistry, there is large number of covalent compounds that differ from that particular concept. That means there is some different type of phenomena occurs that changes the valency of that particular compound, that particular atoms. Like beryllium is valency If we totally focus on unpaired electron, 1s2, 2s2, then this one is inert. But here it forms two bonds, 1, 2. That means here something is missing by us. So when the concept is again studied, or when the structure is again studied, it is found that in the case of the beryllium, there is sp hybridization. So sp hybrid in the if there is sp hybridization, that means 2s and 2p orbital mix to form 2sp hybrid orbital. And in the case of the boron, there is an sp2 hybridization, 1 2s and 2 2p orbital mix to form 3 sp2 hybrid orbitals. And in the case of the carbon, and if you take the example of methane, sp3 hybridization, 1s and 3 2p orbital mixed to form 4 sp3 hybrid orbitals. Okay. Further we study all of these concepts. So first we see that we will study how the valency of that particular atom is increased. Okay. To explain this discrepancy, because according to the concept of covalent bonding, if there is no unpaired electron, then there is no covalent bond. The concept of hybridization is introduced. So on the basis of the concept of hybridization, it is explained why the atom shows large number of valency, but according to the covalent bond, there is in the case of beryllium there is no covalent bond, but according to hybridization, or according to the covalent bonds, covalent compounds available in chemistry, there is an this is in a beryllium is in a divalent. So hybridization involves mixing of atomic orbitals to form new or equivalent orbitals of same energy. Means in hybridization, in sp hybridization, let's take an example of sp hybridization. 1s and 1p orbital intermix to give equivalent hybrid orbitals of same energy. That means there is only one 2 sp orbital. This process allow to form more bond than expected based on the ground state electronic configuration. Means in the case of beryllium, 4 1s2 2s2, this one is the ground state electronic configuration. But if we this one is the ground state, if we talk about excited state, then this one is the 1s2 2s1 2px1. There is two unpaired electron, and that electrons helps in the formation of the further covalent bonds. So in the case of sp3 hybridization, there is 1s and 3p atomic orbitals hybrid intermix to give 4 sp3 hybrid orbitals. 4 sp3 hybrid orbitals. So let's start with the example of carbon to study the concept of hybridization. Carbon atomic number 6, electron configuration 1s2. Sorry, 1s2 2s2 2p2. In the ground state, 1s 2s 2p. One electron, two electron, and in particular one single orbital, we will say one single p orbital, there is maximum two electron, and these two electron must be have opposite spin. This one is the ground state electronic configuration. When the this carbon atom in the ground state, uh, when the this carbon atom in the ground state absorbs some energy, Hv is for energy, heat energy. The electron is excited from the lower ground state to the excited state. Yeah, we can say that lower energy ground state to the higher energy excited state. Electron is excited from lower energy ground state to higher energy excited state. And how this excitation of electron or promotion of electron happens? How this promotion of electron happens? So the concept behind the promotion of electron is that carbon, let's suppose atom A start approaching to the carbon. When the carbon and atom A forms bond, covalent bond, कोवलेंट बॉन्ड एंड जो कोवलेंट बॉन्ड बन रहा है वो प्रोसेस कैसी है? कोवलेंट बॉन्ड फॉर्मेशन इज एक्सोथर्मिक प्रोसेस. And in the case of exothermic there is an release of energy or heat released. That heat helps to promotion of the electron, or we can say that by observing that heat, the electron is excited from lower energy ground state to the higher energy excited state, and in the excited state there is an 4 unpaired electron, and in the ground state there is only 2 unpaired electron. Okay, so with the concept of hybridization we can easily determine the molecular structure and bonding in covalent compounds. So what is the definition of hybridization? The phenomena of intermixing of the orbitals of slightly different energy, because s, p, d, f orbitals have different energy. The phenomena of intermixing of the orbitals of slightly different energy so as to redistribute their energy and to give a new sets of orbitals of equivalent energy and shape is called hybridization. That means here s orbital and 3p orbitals combines to give 4sp3 hybrid orbital. And the energy of these 4sp3 hybrid orbital and this s and 3p atomic orbitals is almost same or nearly to same. There is some characteristic properties of hybridization. That means कि जो हाइब्रिडाइजेशन हो रही है उसके पीछे उसकी कुछ करेक्टरिस्टिक प्रॉपर्टी होनी चाहिए. यानी कि आप कुछ भी हम कह दें कि हाइब्रिडाइजेशन हो रही है. जैसे कि एग्जांपल की अगर मैं बात करता हूँ, मैं ये नहीं कह सकता कि s ऑर्बिटल d ऑर्बिटल के साथ इंटरमिक्स होके sd हाइब्रिडाइजेशन हो रही है. बिकॉज़ कांसेप्ट क्या कहता है कि जो एटॉमिक ऑर्बिटल्स हैं वो स्लाइटली डिफरेंट एनर्जी की हो सकती हैं, ज़्यादा उनकी एनर्जी में डिफरेंस नहीं होना चाहिए. बिकॉज़ देयर इज हैव वन आई हैव मिस्ड वन ऑर्बिटल p ऑर्बिटल. ओके. The number of hybridized orbital formed is equal to the number of orbital that get hybridized. Okay, that means one s orbital plus 2p orbital gives 3sp hybrid orbitals. Okay, one s and 2p give 3 sp2 hybridized hybrid orbitals, not 4, because the number will be same. Okay, next, hybridized orbital are always equivalent in energy and shape. The sp2 hybridized orbitals energy and shape is same. Hybrid orbital are more effective in forming stable bond than pure atomic orbitals. That means the bond forms by sp3 sp2 hybridized orbital is stable as compared to the bond formed by 1s and 2p atomic orbitals. This one is the atomic orbitals. Third one, orbitals are directed in space in specific preferred direction to achieve a stable arrangement. That means three sp2 hybrid orbitals. This one is the center. This one is the sp2 that are arranged in a particular fashion in a particular direction. The type of hybridization determines the geometry of the sp2 molecule. This one is the 3sp2 hybridized orbital and have trigonal planar geometry. Okay. So next, there is some conditions for hybridization, because not every molecules, not every type of combination of hybrid or not every type of combination of the atomic orbitals give hybrid orbital, and although it is valid or not, only the orbital present in the valence shell of the atom undergo hybridization. Okay, only the valence shell orbitals undergo hybridization. The orbitals undergoing hybridization should have only a small energy gap. Should have only small energy gap, and orbitals with a large energy difference cannot participate. Uh, as in the last slide I have discussed, S plus d orbital, not SD hybrid orbital is not valid. Is not valid hybridization. Promotion of electron is not essential condition for hybridization. Okay, it is not mandatory that always for the formation of the covalent bonds or the available covalent structures. For the formation of covalent bonding, there is always a promotion of electron from lower energy ground state to the higher energy excited state. Let's suppose atom A. Let's suppose an covalent molecule AB3. Okay, and A have three unpaired electron. Three unpaired electron. Then there is no requirement of promotion of electron from lower energy orbital to the higher energy, lower energy ground state orbital to the higher energy excited state, because already the three unpaired electron is available, and three unpaired electron are sufficient for the formation of the AB3 covalent molecules. If there is only one unpaired electron available as a molecule A, then there is need to be promotion of electron from ground state to the excited state. And it is not necessary that only half filled orbital participate in hybridization. In some cases, even fully filled orbital of the valence shell also take part in hybridization. In some cases, it is also observed that the fully filled atomic orbitals, fully filled orbitals are also taking part in the covalent bond formation. Sorry, fully filled orbitals takes part in the hybridization. So it is not always mandatory that only the half filled orbitals are considered for the hybridization. These are some conditions for hybridization. Okay. So in this video lecture, we have discussed the concept of covalent bonding एंड हाइब्रिडाइजेशन. आई होप आपको जो कोवलेंट बॉन्डिंग और हाइब्रिडाइजेशन का कंसेप्ट है वो समझ में आया होगा. सो थैंक यू सो मच फॉर वॉचिंग द वीडियो.